I want to talk about why I think that the role of domain expertise in data science is important, and possibly convince you that it's worth investing more effort in learning about your domain. Slides are on GitHub. In the first part, I will argue about why domain is important and introduce the topic. Then I will share a quick intro about the domain I know best, which is logistics and supply chain. Finally, I will go over a number of somehow disconnected stories and ideas on how to make your data science practice more domain-driven. I will also share how a particular technical topic, like forecasting, can be shaped by the domain, and it's different for a particular domain. So we already had an introduction by Alessandro, but I'm Pietro. These are my emojis. And yeah, I have a math background, and a piece of trivia I cannot resist sharing is the fact that here in Bologna, more than a century ago, my great-grandmother graduated in mathematics. So, special place. I've worked almost 9 years in a company that sells a supply chain and logistics software, so that's where my background comes from the logistics part. I know that part about planning very well, but and I'm also part of the community, Python and PyData, and in the last year I've been working in Agile Lab, and I will maybe say something more later. But let's go and introduce the main subject, which is the domain. So when I started in data science, which was a while ago, it was not at all evident what a data scientist does. Maybe it still is not, but something that helped us understand what to do was this so-called data science Venn diagram. I don't know if the young people in the room still see it, but it was a fixture back then. And this tells you that in order to be a good data scientist, you need to have a math, stats background, you have to have or develop skills in writing code, and then you put some domain knowledge sprinkled on top, and then you're a good data scientist. So you go and you start finding a lot of content about the math part. You study it, you learn it about all the algorithms. Then you learn all the cool frameworks and libraries about code. And then you look for the domain and say, okay, but what it is the content about domain? How do I learn it? And my impression, at least, is that there is where we have less content, both in quantity and quality. And this is one of the motivation for this talk, to share what I know about the domain that I learned, in order also to inspire you to share about your domain, because I want to learn about other domains. One of the reasons why I think it's important the domain is because I think it's crucial for the success of a data science project. As technical people with technical background, we tend to think that the success is based on the technology, on the quality of the data that we have, on the quality and the accuracy of the model that we produced, and maybe also on the smooth and the implementation. If we have this in place, we have a successful project. When you grow a little bit more, you learn that things are not like that. There is another side of the story in which you have to convince the stakeholders, which are business people, they're not technical people, that the thing that you have built is valuable. And once you have convinced them, this will be used, and you will have reached the holy grail of data scientists, have something in production. Which is not so easy as it sounds. And one of the theses of the talk is that the domain helps you a little bit on the technology side, but also helps you a lot on the business side in order to communicate with stakeholders and prove and focus on what is valuable, and so reach the holy grail. The name domain-driven data science is inspired by a couple of things, something that is called domain-driven design in software engineering, not much to do with data science, but it's a practice in which developers started to understand, hey, maybe if we write the software and we know what we are writing about, not just know about the code, we write better software. And this has started a big industry in this topic, in which developers try to have a common language with business people. And this, in turn, has inspired, applied to data engineering and data governance, something called data mesh, which is really started as domain-driven design applied to data governance. There is, I think, in general in the data world, a trend about trying to apply best practice from software to data, and this is one of these trends. And as a company, it's something that we have built a part of our reputation also in being expert in this kind of things, and we have released in the last year a short 1-hour free course on the topic if you're interested about it. But these are offsite. So let's go and in the main part in which I share you what I know about the domain of logistics and supply chain, which is, I think it's an interesting old and not so well-known domain, maybe, for some of you. Maybe some of you know it better than I. So let's start with logistics. Logistics is one of the oldest domain because the classic quotes you find in handbooks are about moving goods for war, for example. These are classic quotes. And it's defined as the process of managing the things, materials stuff, goods that you buy, you move, and you distribute in order for customer to buy. And in order to decide how much to buy, when to move it, where to move it, how much to move it and where, you need to match this with the information flow that comes from the market. And two of the main things that a logistic network deals about are storage. You have to put the goods somewhere, usually some kind of variation of warehouses, but it could be also the final point of sales. And you need to transport with containers, with ships, with trains, with people walking, or something like that. And traditionally, also in the past, if you think about data science or AI applied to this domain, you might think about, okay, let's automate this kind of things. For example, you can thinking about automating warehouses. This is something that is, I mean, it's part of the things that are done. But I think that there is a big part of the data science part that is interesting, that is not related to this. Also because this kind of automation is something that requires big investments and tends to have time to take a return on investment. Instead, there is a part of the supply chain area that is mostly dealing with this information flow and using it effectively. And in order to motivate that part, I want to introduce some of the elements about modern supply chain. And supply chain is a term that was invented by a consulting company, Booz Allen Hamilton, in the 70s in order to sell this kind of stuff. And the thing is that in the last 40, 50 years, companies have become more interconnected. You have a more extended network of suppliers. The market changes because the market are more demand-driven in the sense that in the past you used to buy what you find in a supermarket. Now you go and look for that. And you're also used to an increased customer experience. So customers have more demands. And companies in supply chain have found out that with best practices, they can compete and increase both on having an efficient operation, so reducing the cost of the operation, the cost that it takes to move things around, to hold it, to hold capital in stock or something like that, but also in service. Service is the other part of the equation in supply chain. So the fact that when somebody asks you, do you have this, I want to buy it, you say, yes, I have it, okay? And you have it prepared, and you need to prepare beforehand. In this context, supply chain are frequently disrupted by, I don't know, a container that gets stuck in in a channel or volatility with respect to border events. So it has become more complex to manage this information part. And this is where planning comes in. So in the previous company, we made a tool for planners that worked only on the intelligence part. It didn't touch anything, I don't know, inside your warehouse or inside your containers, but it was just moving stuff about data. So that's why it's good for data scientists. And planning in the content, planning means to understand what's going to happen and prepare for it. But in the context of supply chain, you can divide it in 3 parts. So there is one part that is about the demand. You need to understand the historical demand of your customer, and you need to be able to forecast it. And the forecast needs to be probabilistic for a reason that will be clear later. And this is where the part of forecasting that I will deal with later comes from, the need for good forecasting capabilities. You need to forecast it because you will have a stock that evolves, and then at some point you will decide to make orders, and your stock will go up. You don't want to. You don't have an infinite warehouse, so you have to order little by little, time by time, and the stock will go up and down. And the important things tying these 2 parts together, demand and stock, is service. As a business, you decide for different categories of product which kind of service you target. On this part of the service, I don't know, spare parts for luxury cars, I want to have a very high services because these are pricey customers that want to have. They want to order it, they spend a lot for a car. When they need a spare part, they want it right away. And a service in this context means the percentage of my orders that I'm able to satisfy, as a simple definition. And the more you want to be able to satisfy, the more stock you will need to keep because of the fact that there is uncertainty. So the main technical thing which makes hard the whole process is one of the 2 things that I will talk about is uncertainty. And there are 2 things which are uncertain, both the demand of the customer, it's not stable in time, but also the supply. And this allows me to introduce a couple of concepts which are central to this and explain you why forecast is probabilistic, which is something I anticipated. So if we go back to that diagram in which you had stock at a certain moment of time, there is demand that decreases my stock, and at a certain point I decide to place an order. The moment I decide to place an order, the order does not magically arrive, because here we are talking about physical goods. It's not ordering software or something like that. So the goods takes time to be shipped, to be produced, or something like that. And the time between the moment you place an order and the moment the order arrives is called the lead time. And this is something that already in itself is probabilistic. One of the reasons why supply is uncertain. Usually it arrives in a week, but this time it arrived in 2 weeks. And you need to model that probabilistic. So the fact that there is a lead time, that is probabilistic, and also during this lead time, maybe you thought the demand was going slowly, but it went much faster, your stock can evolve to the moment in which it reaches the 0 level, and you have a stock out, and you cannot satisfy the orders, and the customers are not happy about it. So in order to deal with this variability, in this domain, there is one of the pieces of stock that, conceptual pieces of stock that you deal about is so-called safety stock, which is extra stock to mitigate the risk of stockouts. And this is directly proportional to the forecast variability, so the distribution part of your forecast. And that's why in this context, you need a forecast that is probabilistic. So this is the fastest and the simplest I could do about explaining some of the concepts to motivate why we do some kind of forecasting technologies. Something that I want to mention, but I will not talk about, which is the second big area which makes supply chain planning complex, is the existence of constraints which exist in life. You have capacity constraints, you cannot produce so many, you cannot order so many, you have capacity in terms of storage or time. There are integral constraints. You order stuff in multiples. You have minimum quantities. And then there are, in general, other types of constraints, feasibility constraints like schedule, opening hours. And this is a big part of the complexity of this process. And for this, the type of technique is operation research. I would say that the main techniques in this context are forecasting and operation research. I will not talk about operation research. Instead, I will talk a little bit about forecasting in the concept of supply chain. So, in this context, the first thing that you need to do, so forecasting, it is about time series. So in a sense, I was speaking a little bit about time series. And the first thing that you need to do is to model, decide how many time series you need to forecast. And if there is a structure around the time series. And usually you need to take into account and decide how to model 3 dimensions. The product dimension, usually for a supply chain, you need to be able to forecast at the lowest level of aggregation, the SKU, the stock keeping unit, because this is what you need to decide to move around. But SKUs maybe have a very high noise, and SKUs come in family, brands, division. There is a product hierarchy on top of that you can take advantage of, the different level of the hierarchies, because they have business meaning. On the other side, the same kind of products, you will ship them to different regions. And air conditioner will be shipped with different demand pattern in the northern hemisphere or the southern hemisphere. So you need to take into account these 2 different dimensions. And the market is something that for sure you will need to take into account the fact that you will need to forecast the demand coming out of a single warehouse. But maybe the same warehouse serves multiple regions, different customers through different channels, from the e-commerce channel, from the retail channel, from a partner's channel, and maybe it makes sense to separate the demand according to this dimension, because you get a better signal. And finally, you need to decide what kind of minimal unit of time. You need a daily forecast, a weekly forecast, a monthly forecast. For stuff like spare parts that move slowly, monthly forecast is the way to go. You don't want to go weekly. And in order to go daily, you need to have a business case that supports you, because if your lead time are monthly lead times, you don't need a daily detail of forecast. Because by the moment you change the forecast daily, it does not have any impact on the lead time. And so just to have an idea in terms of numbers, if depending on an industry, a company can have from dozens of products to millions of different products. If you go into electronics, e-commerce, you have a number of them. Markets can be a few or 1,000, depending on how you model them. And the time, depending on the unit, you can have, I don't know, the 12 months times the number of years, or the 52 weeks, or the 300 days. So basically, the data set size is not very big. Just to give you also an idea, is tens of thousands, tens of billion range. This is the kind of thing that we deal with. So now you have a model, you have your time series, you need to understand the algorithms you want to do. And something that I like to start with are the most basic model, and something that is used in supply chain in time series forecasting, and is not so well known because I don't know, the classical ones are more well known are RIMA models, is a model which is called exponential smoothing, which is very simple and very stable, in which you update the average of your estimate with the latest value and the weight alpha, that can be something from 0 to 1. And starting from this very simple model, you construct a more complex model, adding the things that you model with exponential smoothing. If you model with exponential smoothing a trend and a seasonality, there's something that in the literature is called as hot winters. If you model for intermittent demand, the moment in which the demand is non-zero and the quantity when the demand is non-zero, you have something that is called Croston, and there's a whole part of a hierarchy of models like that. And recently, of course, machine learning has had an impact on these statistical methods. And let's say that the category of methods that you use and there are used machine learning methods. There are still enough data so that they call for something like GBM instead of XGBoost in some cases. Neural methods can be very specialized. I don't think they're at the moment so widespread. And recently we're starting seeing foundational models. But they may have, it's not something that is very widespread at the moment. You put in place your algorithms, you pick the one. As a data scientist, I try to have a very simple baseline and then take into account the complexity, and you need to start evaluate. So the metric you need to take into account, the classic root mean squared error is a classic metric. Something that I think is useful and is not so evident is the bias in terms at different level of the hierarchy, at global level, at different level of the hierarchy. And this is something that, for example, machine learning staff needs to have special care in order to have a good bias that takes into account the trends and everything, because you want to have, in general, a forecast that is unbiased, that you do not systematically order more than you should or less than you should do. And another one that you can use, let's say that these are the basic three, are the mean absolute error that is more resistant to outlier. If you had demand with peaks, maybe this might be more interesting. Something that is very well used in the industry is called MAPE, which is a very bad one because it's biased, and there are articles, and I link one, telling you exactly why this is not a good measure. And I think one of the things that is interesting is that evaluation then can be very custom and very complex. And something I want to mention is something that happened now a few years ago that is called the M5 competition. It's part of a series of competition on forecasting, but that specific occurrence was on data for supply chain, data from Walmart, from a retailer. And I think that has been a bit of a milestone in this domain because it was an open competition with open rules, a complex way of evaluating with aggregating a weighted root mean square scaled error, because the root mean squared error is not easy to use it when you have to aggregate time series of different dimensions, when you have to compare something that orders very little and something that orders a lot. And so that's another thing that you want to go deeper, is something that is a very interesting read in this subject. Finally, in order to give you another ideas of the things that you can do with data scientists in the forecasting context in supply chain, something that was actually my work in my past company, was to work on engines that dealt with specific effects. So one effect that you have, which is very important, are seasonality, sun creams, ice creams, air conditioners, but also tires are ordered differently in different times and different markets. And this is something that you need to take into account of. And maybe the signal that you have at the lower level is not easy, so you have to aggregate, and maybe you're using some clustering techniques and some aggregation in order to do that. Another classical thing, some industry rely a lot on promotions. Yogurt producers can sell up to 30–40% of yogurts in specific period only on promotion. And when you have a signal that goes like this and then bumps, and like that, it's not easy to make a forecast, and so you need to separate this discrete event and model the uplift separately. And another kind of problem that happens in other industry, like fashion industry, in which you have like shoes or glasses, in which you launch a lot of models every year, is the problem of initialization, because the classical problems of forecasting is when you have a history long enough. But when you have no history, you have to provide an initialization based maybe on the fact that usually product in this category and this market start at this level. And so that's, for example, one of the classical applications in which you might want to be tempted to use machine learning in a classical way as a regression model. I did a presentation of forecasting. I think one of the set of libraries that did a great work in making the Python ecosystem very strong on time series forecasting is Nixla. I did it back then, and I redid it, updated recently, and actually something that I could have added is that one of the most important textbooks in time series forecasting, Hindman, which was R-based, last month got its first Python edition done in collaboration with Nixla people. So that's a new reference that for Python people in the last 5 years, we've gotten a very big boost in terms of what we can use. But that's not the topic of today, the code and the math part. There's always the temptation to go and nerd out about that kind of stuff. The topic of today is domain. So the last part is sharing stories and ideas on how to make your data science practice more data-driven. The first one is the story when I was building one of these product to initialize a forecast, so to forecast a new product, the sales of new products. And we build this model, and we set up the metrics. There is a baseline starting from a process that is done asking around people through Excel that are shared and takes about a month. Instead, we build something in which you press a button, and you have a number that is provably better than the number that is shared. But the problem is that the user don't want to use it. And this is difficult, and for example, one way that we try to go about is to add in, because there was no trust in the model. They see this as a black box, and they say, oh, I don't understand the process. So one way we went about trying to say, okay, I add sharp values, I explain you how this forecast is produced. Does this help? And for me, my lesson learned is not so much. Maybe another direction could be build a forecasting process that is more structured about how they go about the domain, that maybe has some interest into about, because usually they go in a top-down in which, I don't know, there are regional managers that produce forecasts because they know their market and then break it down. And so, and you can take better into account trends and everything. So maybe you have to rethink your modeling approach because of the domain. It's not just about the metrics and the evaluation. So this is at the end of the process in which you have built something and you wanted to use it. But at the beginning, you're looking at data. And so on a more smaller case, one of the other things in which I think it's important to think about the domain when you deal with data is when you are starting to exploring the data and looking at the data that you have. And this is a story when I was exploring warehouse data. So stuff that comes in and comes out of the warehouse. And you have order data. And then I look at the data and I say, okay, there are a lot more rows for outbound orders than inbound orders. But I kind of think that in a warehouse, the amount of stuff that goes in and goes out is the same. So why is this happening? This is happening because, well, in warehouse, stuff comes in into pallet like this. In boxes, you have a supplier that gives you a pallet of the same stuff. But usually, warehouse distribute to point of sales, in which stuff goes out like this, in which your order is not one line of the same stuff, but it is 100 lines of different stuff. And so that's why you have this complexity between the stuff that comes in and the stuff that comes out, which also explain why the picking operation in warehouses is the most costly one, because you have to have people or some kind of process or technology that sorts out the stuff that you need to distribute. And maybe sometimes there is missing data in your order. And when there is missing data, I think you very often need to think about the domain. I mean, it could be a vacation, but it could also be that the Wi-Fi went down at the warehouse and there is no data for the day. And you need to take into account that, and you need to know that. And the other thing that where I think a domain makes an impact is considering one of my favorite rules of machine learning that is also sanctioned by a set of Google guidelines, which is the first rule of machine learning should be to start without machine learning. For various reasons, because machine learning introduces complexity. So if you have a simple heuristics that solves the problem, you should use that one. And you should always start with something simple and evaluate against your more complex model in order to let's say, communicate the value of this added complexity. So you need to evaluate, and then it's better to have in that then a machine learning model which handles the complexity itself than a set of complex heuristics and set of rules to maintain. This is something that the industry has shown. And I think that the domain helps usually in picking simple heuristics that are good. And maybe that simple heuristics also are what you will use in a perimeter that is outside of what you can predict with machine learning. And so they also do some part of the work. So how do you know about the domain? So I think one of the important things that as data scientists we need to be able to learn how to do is to talk to experts. People who are not technical, and who know their domain, and you need to establish a language, and you need to be able to learn with them. And so something which is important is also to practice the interview. You usually have some kind of stakeholders that you need to be in the interview, and you need to be able to understand what they're saying and where there are opportunities to show value and risks that they do not care because they think that what you do is magic, while instead there is nothing magic, we do not extrapolate, and the data quality is always important, so you need to be able to communicate with them. Something that I think is very useful when interfacing with experts is to provide some kind of interface. So another talk that I did was a talk of Streamlit that I've used a lot because it's a very practical tool to talk with experts because they also find a nice UI. So I think that some kind of interactive tool that shows the data you're dealing with is important to talk to experts and have them connect with the data, which usually have trouble doing that. Another thing that you can do with the domain, so we know that documenting code is good, but maybe we should start documenting the domain, or at least a little bit of the domain. Something I started to do in my projects is add very few lines in the README, which I called the business, domain, and data essentials. It could be very, very few lines, but it helps you anchor your problem to the business value, to the specificity of the domains, and to what you actually have that should provide value, which is the data. So you might have a specific project which tries to improve a process by reducing cost. And in that domain, reducing cost can be in improving a specific process, and there is a common way that is used to improve that specific process, and you should track it down because this is something that people know, and you need to be able to improve on that. And but you also have to keep into account the data that needs to come from a system, and you need to know a little bit of the specificity of the system. Warehouse management systems that have their own life cycles, how many years of data, what happened during that data. Usually they start to implement process, and you have good data from some moment on. Okay. Another thing is that you might want to learn about the domain. And there are a number of ways to do that. There is no shortage of influencers nowadays, and I think they are a useful thing. Sometimes they are incentivized to talk about a lot of stuff and complexify stuff. But when I start working on the project, I try to find these influencers nowadays on LinkedIn or in other places and try to read, because these are people specialized in the domain. And this Nicolas Van de Putte is one of the people that is doing a lot of work in the forecasting and optimization domain that I cited a couple of times. You should rely on experts, and not only the experts you find in the project. Something that I discovered is that, well, in YouTube you find really everything, and I don't think we realize how much there is, but now that we see this LLM and AI that creates magic stuff, it's because stuff is there in YouTube, in corners that you don't know of. And I was working for the first time on warehouse stuff, and I found these two guys, warehouse experts, very basic, no data, no nothing, that explain you all the basics of the process. And the next process, the project that I did on something that was network, I go and look on YouTube for simple people that explains you that. And when you go to a meeting for a customer or for your stakeholders, that you have watched a 5-minute YouTube video on that topic, you have a much better performance on the interview process and what you can extract in terms of information about the domain for the interview. Finally, if you are investing in a specific domain, you should also study books. And another thing, but this is just purely speculative, is something that sometimes you might want to get inspired by the domain. So one of the last projects I worked on was in this warehouse concept. There are these lean processes by the Japanese in which they try to put in a warehouse, they need to sort everything, straighten, make it shine, because when everything is clean, people work better. You have to standardize, and I don't know, this kind of methodology is something that for me, it reminds me a lot about a data pipeline. So I'm still tempted to write a 5S methodology for data cleaning or something like that. At some point, maybe I will do it or not. Okay. So, I hope I have convinced you that the domain is a worthy and relatively untapped opportunity for data scientists. Maybe you realize there is more complexity, more intentional things that you can do in these things. It's not just something that, yeah, there are the domain experts, I lost them, but we can learn as data scientists. We don't have to become domain experts. We have to become data scientists expert in the domains. And hopefully some of you will be inspired to learn more and share, because I want to watch your talks about your preferred domains. So thank you for listening. And I work now in Agile Lab, which has a public handbook, which is a nice thing to learn about how a company works. And a couple of things that, if you want, you can ask me later, is about our self-management system, which is also an innovative way of managing your work and distributing authority and accountability. Or we have a number of other benefits, like a nomads program where we work from places like Canary Islands a couple of weeks. Thank you.
Thank you very much, Pietro. I have a question, which is, sometimes domains are great, and you dive in them a lot, and you can lose them in them, yourself in them. So how do you stop? How do you know that you know enough to solve your problem?
That's with everything. Also with the technical part, you can dive and can know how to stop. I think the important thing is to realize what's the goal of the thing that you are doing. And try to start from there, and try to do only what's necessary for the next step, trying to go...
So try to have an iterative...
I don't know, I try to make it simple, to clarify very simple the goal, and then try to understand, okay, but these things in which I want to nerd out, is it really necessary or not? And the other thing I try to do is I pack it as a nice to have, and I say, okay, these are the important stuff that I need to do first.
Okay.
And if I've done that, then I can do the nice to have. I never get to the nice to have.
Okay.
But I'm happy anyway, because the important stuff turned out to be more interesting enough.
Okay, thank you. Yes. There is another question from Francesco, who said, I tried reading the blue book about the DDD, but it's so boring. I couldn't get past the first chapter. How can you help me?
There is another reference, which is an interesting one, which is Cosmic Python. There is a book that tells you about architecture patterns and domain-driven design done by two Pythonistas, not by Java people. That's why you find the domain-driven design book boring. So cosmicpython.com. The name of the book is different. They wanted to it's an O'Reilly published book. They wanted to name the book Cosmic Python. And there is a reason for that. You find it on the website, but the editor didn't allow it, and so they registered the domain, of course, which is what you do, and the name of the book is something more enterprisey.
I don't have any more questions here on Slido. I don't know if there are any in the audience.
There is a coffee break.
There is a coffee break. Okay. Yeah, so if there are no other questions, last round of applause for Pietro.
Thank you.
Thank you very much.